12, it says the dashed line in the figure shows where a cut is to be made in a rectangular piece of sheet metal. Find X. All right, so X, if you look at the picture carefully, starts here and goes to there. It does say this is a rectangular piece, which properties of rectangles say that these opposite sides are the same length, these opposite sides are the same length. So I happen to know that if this is if this is 18 inches, so we'd have to know either this or this, so we don't really know what that is or that is. But that is 28 and that's 12, so that means that this piece here would have to be 16 inches.
Yep.
Okay. The other thing I recognize in this picture is this triangle that they've cut out is a 36-90 right triangle, which we dealt with on Friday. 36-90 right triangle, if you recall, I draw the similar triangle to it. 60 degrees goes here and 30 degrees goes up here. I'm drawing it oriented the same way. So when I'm drawing it, I always want the orientation the same as what I'm looking at my picture. So I got 30 up top. I've got the right angle in the bottom right corner, the 60-degree angle in the bottom left corner. And the smallest side, angle 30 is opposite smallest side 1. The biggest angle 90 is opposite the biggest side 2. And the middle sized angle 60 is opposite the middle sized angle square root of 3. The number is 1, 2, square root of 3 every single time. Square root of 3 is about 1.7, so it's in between 1 and 2. 1's opposite smallest, square root of 3 opposite middle, 2 opposite biggest. This triangle here is similar to that triangle there. And the piece I want to know is this piece down here. Let's just call this piece A. If I can figure out how long A is right here, then I can figure out X is A plus X is equal to 18, right? So if A is whatever, 18 minus A is equal to X. That's what's going on here. So if I use my right triangle relationships, the 16-inch side corresponds to the square root of 3 side, and the A side that we're looking for corresponds, wait patiently here, there we go. A side corresponds to the side that's 1. All right, so again, by drawing them in the same orientation, I can make sure that the corresponding pieces do get in the same places, so it's easier to identify. So if I make my proportion now, and I put the 1 and the square root of 3, let's say, on top, and then the corresponding piece to 1 is A, and the corresponding piece to the square root of 3 is 16. It doesn't matter what I put on top, what I put on bottom, just as long as I put the things from the same stuff on top, same triangle on top, same triangle on bottom, and the corresponding pieces in the same fractions. So just to give you an idea of that, if I'd put the 1 and the square root of 3 on the bottom, 1 still goes with A and the 16 still goes with the square root of 3. They look like they're different proportions, but if we look at the cross products happening, the next step is cross multiply. I got the square root of 3 times A, and I got 16 times 1. So it doesn't really matter where you put them, you're going to get the same cross products happening. So don't get really hung up on which one's supposed to go on top. It doesn't matter. Pick one triangle to go on top, put the corresponding pieces of the other triangle on the bottom, and then cross multiply to create the answer. So either one I'm looking at, I'm going to get the square root of 3 times A is equal to 1 times 16. Divide both sides by the square root of 3. We typically find approximate values in this class. If I grab my calculator now and I type in 16 divided by the square root of 3, that comes out to 9.24. It doesn't specify number of decimal places, so I'm going to go 2. So 9.24 inches. The question says find X, and again, I had to find A to be able to find X. So 18 inches, these two pieces make 18 inches, so 18 minus A is equal to X. That's the relationship between AX and 18. What I'm looking for equals 18 minus what I found. So X should equal 18 minus 9.24, which equals 8.76 inches. If I was using a regular ruler, 0.75 is 3/4 of an inch. So if I was ballparking at 8.8 3/4 inches, what I would probably tell the person trying to do this. I cut this at 8, like make a mark at 8 3/4 inches there. make a mark at 12 inches there, cut across, you should be getting pretty close to 3690 right triangle, probably close enough for inspection purposes.